Electrolysis of the molten, dilute, and the concentrated electrolyte has the objective of decomposing the compound into the elements. Right? So if you look at the electrode used, these electrode used are also inert electrodes. So what we mean by inert electrodes, right, is that when the current is switched on, the electrodes remain intact. Okay, I'll use one example to compare. So the inert electrodes are basically the cathode, the carbon electrode, or the platinum, or the graphite. So let's say we talk about this sodium chloride solution. Okay, both of them are the inert electrode, that is the graphite or the carbon. When we turn on the current, the Na+ ions will get attracted towards the cathode. Okay, so at the cathode, we will have the Na+ ions the H+ ions be attracted towards the cathode to undergo reduction to form the hydrogen gas. At the anode, we said that we will have the hydroxide ions to undergo the oxidation to form water, oxygen, by losing 4 moles of electrons. Okay, so that's what's happening in the use of the inert electrodes. The use of the inert electrode to decompose the electrolyte into the various elements. However, when we want to carry out electroplating, we cannot use inert electrodes anymore, but instead we will have to use the active electrodes. Alright, so how does the active electrodes work? So let's say when we want to electroplate an object, always remember to put the object at the negative terminal of the battery, making the object to become a cathode. We're making the object to become the cathode. And then you can see that the metal, okay, this piece of anode must be the metal that you want to plate on the object. For example, we want to plate copper on the object, then we must use the copper electrode. So we no longer use inert electrodes like graphite, platinum, or the carbon. Instead, we have to use the relevant metal electrode that is going to be plated on the object. Now then, what about the electrolyte? Now the electrolyte must contain the metal ions that are the same as the metal that is used to plate on the object. For example, we use copper metal to plate on the object, then we must use copper-based electrolyte, such as the copper 2 chloride, copper 2 nitrate, or copper 2 sulfate. Can we use copper 2 carbonate? Obviously not, because it is an insoluble salt. So these are the various types of copper-based solution that we can use to use as the electrolyte. Okay, now when the current is switched on, what's going to happen first is this copper electrode will get oxidized. That means the copper electrode will take part in the reaction like this. So at the anode, the copper metal will get oxidized to form the copper 2+ ions and losing the electrons. Okay, now at the cathode, what happens is, while the copper metal is being oxidized to form the copper 2+ ions, that means over the time, this will become smaller and smaller, it gets depleted. Oxidized means the piece of metal, copper metal, will get smaller and smaller and get dissolved into the solution. So while this is happening, the Cu2+ from the electrolyte will get discharged at the same time towards the object, towards the cathode. by undergoing reduction to form the copper metal. So eventually there will be a layer of the copper metal coated on the object itself. So you have to understand that the copper ions that gets discharged at the cathode does not come from the oxidation of the anode. These two copper 2+ ions are from different sources. This is from the electrolyte. Whereas this Cu2+ comes from the oxidation of the copper metal. So both directions happens at the same time. That's why you cannot expect the copper 2+ ions to be coming directly from the copper metal. Now many students have this misconception. They thought that the Cu2+ from this at the cathode, right, is actually coming directly from the metal. No, it's not. It's from the electrolyte. So in other words, it's very important to choose the correct electrolyte. If you don't use the same metal electrolytes, then you are plating a wrong type of metal. That's how the electroplating works. Now, what are some of the implications that you must understand from here is that because of this process, you can see that the copper metal becomes smaller. Not only that, when it turns into the copper 2+ ions, it gets into the solution. But at the same time, the Cu2+ ions from the solution will also get discharged towards the cathode. So there is a constant replenishment of the Cu2+ ions from the anode into the electrolyte. That's why the electrolyte will not become colorless, even though the Cu2+ ions from the electrolyte gets discharged. Let's write that down. The color of the electrolyte remains blue although Cu2+ ions are discharged from the electrolyte to the cathode. Because there is a constant replenishment of Cu2+ ions from the oxidation of the copper metal at the anode. The copper metal will get oxidized and keep producing Cu2+ ions to the solution. And the other way to look at it is, you can see the mole ratio are all the same. 1 mole of copper metal produces 1 mole of the Cu2+. The same amount of 1 mole of Cu2+ will also get discharged towards the cathode to coat 1 mole of copper metal on the object. So that's what we meant by constant replenishment. So the copper metal will become smaller and smaller until it disappears, and then the electroplating will stop. Understand the whole process, right? So if you compare the use of this active electrode, that's in the application of electroplating, okay, versus, let's say I give you another example, the use of the inert electrode. So we use graphite electrode. Now we change this electrolyte to a copper 2 sulfate. A copper 2 sulfate solution, but we are using carbon or graphite or the platinum electrodes. This will cause the solution to become colorless. So what are the ions that will be discharged? At the cathode, you will have the Cu2 plus ions to undergo reduction to form the copper metal. And then at the anode, we will have the hydroxide ions to be discharged. Like this. The electrodes will not take part in the reaction immediately when the current is switched on. The electrodes will just be there as a terminal to collect the products. Okay, at a cathode, because of the production of the copper metal, this copper metal will get coated on the surface of the cathode as reddish brown solid. So what are the implications? The implications is that you will see reddish brown copper metal coated on the cathode. Okay, the blue solution or the blue color of the copper 2 sulfate solution will get decolorized. So in the exam question, they will usually discuss about the difference between these two setups. One using the inert electrodes, the other one is using the active electrodes. And then what are the differences? So yeah, so that's the difference between the use of active and inert electrodes. But then you must also take note that the meaning of inert electrodes doesn't mean that the elements of the electrode used are unreactive. Okay, like for example, we say platinum, graphite, and copper, they can still react because they are not considered to be unreactive matters or non-matters. It's just that in the context of electrolysis, when we use the word inert, it means that they are not taking part in the reaction immediately. Unlike this kind of active electrodes, once you turn on the current, this will get smaller and smaller, it gets depleted. That's called active electrodes. Okay, so in the context of this electrolysis, the inert electrodes, right, it also means that the graphite, carbon, and the platinum electrode cannot be used forever. No? They will still have to be changed, especially when one round of electrolysis is completed. Because after all, they are affected by the oxygen from the surrounding and also from the anode. You can see that most of the time, the anode are the ones that will get affected. The anode inert electrodes will get worn out very easily because it produces oxygen gas. Or in the case of the concentrated solution, it produces the chlorine gas if the Cl- ions are being discharged, right? Remember? Yeah, so chlorine and oxygen are very strong oxidizing agents. They can actually cause the anode to be worn out very easily. So we have to also change these electrodes constantly. Usually in the industry, right, they will change all these inert electrodes after a few rounds of runs in the electrolysis process. So that also adds on to the cost of the electrolysis because platinum and graphite are very expensive. Got it? Yeah, so there's actually exam questions where they say that what are the other side products that will be produced in the use of the inert electrodes? So other side products are carbon dioxide. Because if you use the graphite anode, this oxygen here will react with this carbon to form carbon dioxide or even carbon monoxide. If it's chlorine, then it will form the platinum chloride if you are using the platinum electrodes, depending on what electrodes are used or what materials of the electrodes are used.